If you enjoyed this podcast, please consider liking, sharing, and subscribing to the channel. The Phantom Connection. The scientists who followed these strange clues made an even wilder discovery. They found that two tiny particles could share a ghost-like connection. When they split a single particle into twins, something amazing happened. These twin particles stayed linked forever. It did not matter if you put one in New York and sent the other to Tokyo. Touch one particle, and its twin would react right away. Change the spin of one, and the other would flip too. The reaction was instant. Einstein saw this and felt sick to his stomach. He called it spooky action at a distance. How could one particle tell its twin what to do faster than light could travel? It seemed impossible. Einstein fought back. He said hidden signals must exist between the particles, secret messages we could not see. But when scientists tested this idea in the 1970s, they proved Einstein wrong. The spooky connection was real. The mathematical monster. When scientists tried to merge gravity with quantum rules, something terrible happened. The math exploded. Picture this. You have a calculator that works perfectly for adding, subtracting, and multiplying. But when you try to divide by zero, it screams error and dies. That's what happened when physicists fed gravity into quantum equations. Richard Feynman was one of the smartest people who ever lived. He could solve problems that made other scientists cry. But when he tried to calculate how gravity behaves at the tiniest scales, his equations gave him infinity. Not big numbers, actual infinity. This wasn't like getting a wrong answer on a test. This was like asking, "What's 2 plus 2?" and getting "purple elephant riding a bicycle" as the answer. The same math tricks that tamed electricity and magnetism became useless against gravity. Every attempt to force these two worlds together created mathematical monsters that devoured meaning itself. Scientists realized they weren't just missing a piece of the puzzle. They were holding two completely different puzzles that refused to fit together. The thief in the dark. In 1974, Stephen Hawking made a discovery that sent chills through the physics world. He found that black holes were not the perfect darkness everyone thought they were. Instead, they glowed. Hawking used quantum rules to study what happens right at the edge of a black hole. He discovered that tiny pairs of particles kept popping up from empty space near this boundary. One particle would fall into the hole while its partner escaped into space. This made the black hole look like it was slowly bleeding energy. The escaped particles carried heat away from the black hole. Over billions of years, this meant the hole would shrink and finally vanish completely. But here came the real problem that made physicists panic. When the black hole disappeared, where did all the information about everything that fell inside go? A book? A star? A person? Their details should exist somewhere according to quantum rules. Information cannot just vanish from the universe. But Hawking's discovery suggested it could. The black hole would eat the evidence of everything it swallowed, then disappear itself. The hidden rooms. The math told a strange story. When scientists tried to make the equations work, they kept hitting the same wall. The numbers only made sense if reality had more rooms than we could see. Picture a guitar string. When you pluck it, it vibrates and makes music. Now imagine the tiniest possible strings, smaller than anything we can measure. These strings dance in space, but not the space we know. They need 6 extra rooms to exist. These hidden rooms are curled up so tight that we walk through them every day without knowing. Think of a garden hose. From far away, it looks like a line. But get close and you see it has width and depth. Our world might be the same trick played on a cosmic scale. When these tiny strings vibrate in different ways, they become different things. One pattern creates what we call an electron. Another makes light. Most exciting of all, one special vibration acts like the missing piece scientists have hunted for decades, the particle that carries gravity itself, the universe on a wall. Scientists found something so strange it makes your head spin. Picture this. Everything you see around you might be fake. Not fake like a movie. Fake like a shadow on a wall. In 1997, a physicist named Juan Maldacena made a shocking discovery. He proved that a world with gravity could be perfectly copied by a world without gravity. Think of it like this. Imagine you live inside a ball, but everything about your life can be written on the ball's surface. This sounds crazy, but it's real. Just like a hologram on your credit card looks three-dimensional but lives on flat plastic, our universe might work the same way. Every star, planet, and person could be information stored on some distant boundary. This discovery helped solve part of the black hole mystery. Information doesn't disappear into black holes. It sits on their edges like writing on paper. But now we face a bigger question. Which world is real? The one we feel or the one on the boundary? The random gamble picture? Space itself as an old wooden floor that creaks and shakes. That's how Jonathan Oppenheim sees gravity. His wild idea says space doesn't follow quantum rules at all. Instead, it woggles randomly like a drunk person walking. Most scientists think everything must be quantum deep down. But Oppenheim said no. He thinks space stays normal, while tiny particles dance their quantum dance on top of it. The floor shakes, making the dancers stumble in weird ways. This fixes old math problems that made scientists pull their hair out for decades. No more endless numbers that broke their computers. But it comes with a price. It throws away the dream of one perfect theory that explains everything. Other scientists got angry. They started fierce arguments. Some designed experiments to test who's right. Maybe the answer isn't pretty at all. Maybe it's just a messy compromise that works.